Hello friends, welcome to my channel Master the Monster. Let's enter into the world of polynomials. Trust me, this is going to be an easy and interesting section of mathematics. You may have few doubts and questions regarding polynomials, the degree of polynomials, zeros, division of polynomials, what are quadratic polynomials, geometric meaning, all those things in your mind. No worries, let us sort out all the questions one by one. Before that, subscribe to my channel so that you will enjoy learning maths. Class 10 Cbse Maths Chapter 2 Polynomials Exercise 2.3 Problem number 5. Give examples of polynomials p of x, g of x, q of x and r of x which satisfy the division algorithm and degree of p of x equal degree of q of x. In the next case, degree of q of x equal degree of r of x. And in the next case, degree of r of x equals 0. They are given some restrictions for these four polynomials. So we have to find p of x, q of x, g of x and r of x. That is the four polynomials which satisfy these restrictions, right? Okay, now let's consider the first subdivision. The first subdivision is that degree of p of x should be equal degree of q of x. That is degree of dividend equal degree of quotient. See, you can write as many examples for this problem. I am going to give you the one and the simple examples for all the three subdivisions so that you can understand easily and you can extend it according to your level of creativity, right? Okay, now you consider the dividend and the quotient. If you take a polynomial, the dividend is a polynomial of degree 2. The quotient should also be of degree 2. If it's of degree 3, it should also be of degree 3. So when is it possible? You'll think over it only when the divisor is just a constant. So you don't have any x. Because if you have x square and you divide one x, you will get the degree of x will reduce. Okay, so you don't want the degree of x to be reduced even after division, then you have to divide it by the constant. So I am going to take my dividend to be a polynomial of any degree. It can be any degree. And the divisor g of x to be a constant. So when you divide a polynomial of any degree by a constant, the degree of the polynomial will not decrease and the quotient will be of the same degree. So, using this, let me take p of x equal to 5x square minus 10x plus 5. Okay. And let me take g of x to be a constant. You can take any constant. In an easy way, see 5 is a common factor here. So, let me take 5 itself as its constant. Okay, so when I divide this p of x and the g of x, you see when you divide, you need not go for division itself. You can divide here itself. 5x square minus 10x plus 5 divided by 5. You can take 5 common outside from the numerator. So it is x square minus 2x plus 1 divided by 5 gets cancelled. So this is my quotient q of x. So q of x equal x square minus 2x plus 1. And reminder r of x, as it is a factor, the r of x is 0. Right? So here degree of p of x is 2 and here degree of q of x is 2. Therefore, we have found polynomials satisfying the condition degree of p of x equal degree of q of x. Consider the second subdivision. Given the second subdivision is degree of q of x equal degree of r of x. That is degree of quotient equal degree of remainder. Degree of q of x to be degree of r of x. For that, first let me consider the divisor g of x. Okay. Now, to write the simplest example, let me take this g of x as a quadratic polynomial x square minus 2x plus 1. Alright. Now let me take p of x as by multiplying a common term to this polynomial, that is g of x. Okay, suppose let me multiply this g of x by some 3 or 5 or 2, anything. So let's multiply. So I take x square minus 4x, and be sure if the constant term also you can multiply, otherwise the constant term alone you can change. Let me take some 5. Okay. So if you consider polynomials like this, then when you divide, see here it is 2x square minus 4x plus 5, and here it is x square minus 2x minus 1 plus 1. So when you divide the first term of the divised by the divisor, you get the quotient to be 2, so that you get 2x square minus 4x plus 2. So when I subtract, you get it to be, see, 3. So here q of x equal 2, and degree of q of x is, since q of x is a constant polynomial, it is 0. Degree is 0. And r of x equal 3, and here again degree of r of x is, since r of x is a constant polynomial, here also degree is 0. So we have got the degree of quotient and degree of remainder to be the same. So this is how, in the simplest way, I have found two polynomials satisfying degree of quotient equal degree of remainder. Okay, you can also use some other polynomials. You can also check it for some other polynomials in some other ways, right? And the third one is degree of r of x equals 0. You can consider the same type itself. So degree, second subdivision and third subdivision can have the same type. So see here degree of r of x equals 0. So this is a polynomial. So p of x, q of x, g of x and r of x are polynomials satisfying degree of r of x equals 0. So you can consider the same example for this also. Otherwise you can try different examples for cubic or 4 polynomial or whatever it is, right? So hope you understand. Thank you.